Hello everyone and welcome to the second solution of the longest substring without repeating characters problem. So, I've just taken an example. Let's think, what's the natural thing to do here when you want to find this longest substring? Of course, let's try to find the longest one, which starts with the first character. So, my substring will be initially A, which is definitely a good one. Then I can take also the character B. Then I can take C, and I see that I can take A. So, the longest substring that I found so far is this one, of length 3, and the problem was that I couldn't have also taken this character. And why is that? Because I already have a character in the current substring which is equal to A, and that character is this one. This means that if I ever want to find a valid substring which also contains this character here as a 3, I will have to get rid of that one. So what I'm going to do here is reduce my current substring to the one which doesn't contain that character. And now I have BC. Obviously, because I got rid of the bad character, I now am able to take the next one. I can take BCA. I can also take D. And if I try to take the C, we have a problem. What's the problem? Well, of course, I can't take this character because I also have a character here which is equal to C. And the character is this one. The answer so far is 4 because this current substring is longer than the previously found one. But if I want to move on and find maybe longer valid substrings, those substrings will have to contain this character. And in order to find a valid substring which contains this character, I need to get rid of this one. Well, because it will still have to be a substring, I can't get rid of that only by removing it, right? I can't have the substring B, A, D, C. So what I need to do is actually remove all the characters from the current substring which are also on its left. So I will have to remove B and C. So now my current subarray, instead of BCAD, is going to be AD. And because I got rid of the C, I can now extend and take the C. I can take the E. And what happens is that I cannot extend anymore. That would have meant to take the character D, but I also have a character D in my current substring. As you can see, its length is 4, so the answer is still going to be 4. And if I want to try out the substrings which contain this character, I'll have to get rid of this one. So what's going to happen? Well, I'm going to get rid of this character and also every character on its left from the current substring. So now my current substring is CE. I can take the D, I can take B, and here I stop because the next character is E. Following the same line of reasoning, if I want to try out the substrings that contain this character, I have to take a look in the current substring, find where the character E appears, which is here, and remove him and all the elements on its left. So now my current substring is DB, and I can take E, and as you can see, I have no more characters left. So the approach is pretty simple. If let's say this is the string on a general case, right? I start with a pointer, I equals 0, which means that I'm going to find the longest substring, which is a valid one, and starts on this position. And let's say I found it. Let's say it was this one. Then I know this one is a valid one. Let's say this is my endpoint, J. So first of all, I stopped here and I didn't take the character on position J plus 1 because I'm going to have a character here which is equal to it. Let's say this was A, for example, right? And I obviously had some A here, for example, and these two are equal. So what's going to happen is that now I is going to be equal to that position where the character A appears. Let's call it P. I will become equal to P plus 1. So the new I is going to be here. And now that I've got rid of this A, and of course, all the characters here are different, we know that, my current substring is going to be now this one, I, J plus 1. What do? Of course, I try out more characters. Let's say I found a couple of them which weren't encountered yet. So J will be here. And now, of course, I couldn't take this character because there is probably one here which is also equal to it. Let's say this character was an X, I don't know. And let's say we know we have some X maybe here, right? So what's going to happen? In order to try out the substrings that contain this character, I need to know the position where an X was encountered the last time. Let's call it P. And I need to move again the starting index on that position, P plus 1. Now everything is going to be fine. I can also take this character. So the J will end up here. The I will end up there. And then, of course, move on and try to find out more and more characters to take into my current substring. And this is it. What I do now is that I basically try out each and every ending index. So I always try to push more and more characters into my current substring. And when I do that, because my character might already occur in my current substring, I need to check that. If that happens, I need to know what is the position where that character occurs and just set the starting index to that position +1. So the only information that I need now is what is the last index where I found a letter from A to Z. And because I am already iterating through the characters of my string in chronological order with this end index, all I need to do is store another array, which is similar to the frequency array, but this time, instead of counting for how many times one character appears, it just stores what is the position where we have encountered that character last time, or -1 if we didn't at all. Alright, and this is the code. As you can see, I have my array, last occurrence, which is going to store the last position where each character, each letter from A to Z has occurred in my string. It has a size of 26, initially filled with -1s. This value -1 is going to tell us that that character hasn't been occurred yet. So answer is initially 0. We have the start index of our current valid substring, which is going to end in J, which is our end index. I try out each and every end index from 0 to n-1. And whenever I want to add to my valid substring the new character s of j, I first check. If the last occurrence of that character is greater than or equal to I, so this character actually occurs in my current substring, which is I and j-1 so far, right? I just have to ignore him and all of its characters on its left. So I becomes last occurrence of sj-a +1. And then after this, I set the last occurrence of the character to be equal to j because I'm going to need it in the future. I update the answer, and in the end, I just return the answer. Cool. So what's the time complexity of the algorithm? Of course, we have here a big O of sigma, 26 characters. Then these two are constants. We have this for loop, which makes n total iterations. And as you can see, everything here is a constant, right? And of course, the returning is also a constant. So the final time complexity of the algorithm is big O of n plus sigma, or just big O of n, and the memory complexity is big O of sigma. And this is it, guys. As simple as that. You could have come up with this solution without knowing the theory or two pointers techniques or stuff like that. I hope you enjoyed it. Have fun coding, and I'll see you on the next one. Bye.